All right, great. Yeah, thanks everyone for coming. For anyone I haven't met, my name is Mike Burnett, and I work with the Nature Conservancy. And I'm very fortunate to get to work with the Soil and Watershed Management Working Group of the South Kohala Coastal Partnership. And for the last couple of years, I've been helping out on this project to try out different restoration methods in the dry Pelekane Watershed with a variety of partners. And I'm excited to share some preliminary results from that today, as well as some other land cover mapping efforts that I've been working on in the watershed to help track its response to different management practices and help target future actions. And so first I'll start with just a little introduction to the watershed and some of the environmental issues that we are facing on that landscape. And then I'll talk about the design of the restoration trial, some of the early findings that we've had after about a year of running that experiment. And then lastly, I will get to the vegetation cover mapping. And so this red outline here is the Pelekane watershed as it's currently defined by our National Hydrographic Database. It's about 14,000 acres between Kauai and stretching up in the direction of Waimea. As you can see, it has quite a bit of environmental variability. At the top of the watershed, you have a little sliver of native cloud forest that is very wet. Down at the bottom of the watershed, it is very dry, only about 8 inches of rainfall per year. And in that lower environment, it's a very dry rangeland, I guess I would say, mostly dominated by invasive fire-prone grasses. Now, most of this watershed either drains into the harbor here via this gulch or down into Pelekane Bay down here through this other gulch system right here. The major landowners in the watershed are the Queen Emma Land Company, who's been a terrific partner throughout this project, as well as the state of Hawaii. And so this watershed, unfortunately, has for many years suffered from pretty severe erosion problems, which subsequently has downstream effects on the water quality in Pelekane Bay. And the main drivers of these erosion issues are really wildfires and overgrazing, both by cattle and feral goats. And this is an amazing picture, kind of just showing how stark that difference is between, on the left, you have an area where goats had been controlled to some degree for a few years. And on the right-hand side of this fence, you have an area where there was no goat management going on. And as you can see, there's barely any grass cover on the right-hand side of the watershed. And so the problem this creates is that when it does rain, and even though these are dry watersheds, the rain tends to come in very intense sporadic rainfall events. When it does rain, huge amounts of sediment, many thousands of tons per year end up washing off of these slopes into the channels and eventually out into the ocean, which is detrimental to the coral reef ecosystems out on the coast and just the general water quality. Some of you may have been swimming out in Pelekane Bay after a rain event. It gets pretty soupy in there. And so these are the problems that we really want to mitigate. And here is actually another great picture of kind of the worst case scenario that happened in 2015, where there was a severe wildfire that burned up into the slopes of Pelekane on this hill slope here. And it was shortly after followed by a very intense rainfall event, which caused a large amount of flooding and brought all of this dirty sediment-laden water out into Pelekane Bay. And so this is kind of like the very extreme illustration of this problem and the effects that it can have on coastal water quality. And so when thinking about how to manage this problem, obviously the first steps are to attack the stressors, to manage grazing better by controlling feral ungulate populations or changing cattle grazing strategies, and then also improving your fire infrastructure, reducing fuel loads near roads, just to try to keep those severe wildfires from starting. But in these really dry ecosystems, it's probably going to take a really long time for vegetation to establish itself. Like when you look at the right-hand side of this fence line, in some of these really bare areas, just removing the stressors you may still need a few years to actually get significant vegetation cover back on this landscape. And so we're really wondering with this project, how can we accelerate the regrowth of that vegetation? And maybe can we actually, shift that toward a more diverse mix of native species that used to inhabit this landscape, but have been replaced by these really fire-adapted invasive grasses. And so with that, we decided to design an experimental trial to look at different revegetation strategies and figure out what might work well in this watershed. We chose an area that's pretty representative of the really degraded areas of Pelekane. You can see all of this exposed brown-red soil that has been overgrazed by feral goats. And we decided to locate our trial right here where you see this polygon because it's close to this nice access road and captures just the really poor state of this landscape. And you can see right down here, this is that gulch that eventually drains straight into Pelekane Bay. Here's another aerial picture of that landscape. We situated the trial right on this bald spot right here where a lot of the topsoil has been washed away and vegetation cover is between like 5 and 15%, depending where you are in this area. And here's a layout of what the experiment actually looked like. These were pretty small plots, about 2 meters by 5 meters. And in each plot, we tried out a different treatment. It was a fully replicated design that we designed to be able to be sensitive to changes in vegetation cover of about 10% or less. And it was mostly randomized throughout this spatial arrangement. And so within here, we were testing 8 different restoration strategies and a few controls as well. And I should mention that this trial is all taking place on land owned by Queen Emma Land Company, and we worked pretty closely with Forest Solutions to establish the whole thing, build the fence line, get the treatments on the ground. So they've been incredible partners to have through this project. First, we went ahead and built a 2-acre fenced exclosure to keep out goats and cattle. At the same time as this experiment was going on, there has actually been an effort to control the goat populations within this area, but the fence was still good for those initial 6 to 12 months when there still were a lot of goats in the area. And in the future, it will help keep cattle out of the experiment as well. Forest Solutions set up a broadcast irrigation system that was fed by tanks above the trial. And we did have to truck water a short distance through the watershed to get it from an existing tank to these tanks. If we were ever to scale up any sort of restoration that included irrigation, we would want to try to set up a more efficient system. But for this small restoration trial, we decided this was the most convenient way, given that it's really close to the road. And now I'll talk a bit about the actual treatments that we were testing. The first one is the simplest, it's just plain old seed scattering. And we tried it with 2 different seed mixes. One of them was actually that buffle grass, which is the dominant non-native grass in this area. And we decided to go ahead and try this, even though it's not, our ideal, a native grass species, because it is so dominant and successful out there that if we really have the goal of just increasing vegetation cover to help slow down erosion, it really might be the best bet for some of these really, really dry areas in South Kohala. But we also tested a diverse native seed mix with these 6 species in it. That's peely grass, a'ali'i, uhaloa, ilima, iliahi, which is sandalwood, and willy willy. So some of the classic dryland species that would have inhabited this region before the introduction of ungulates. The next couple of treatments we tried were hydromulching. And so hydromulching is actually where you make this kind of slurry here of water, some kind of fiber like wood pulp, and all of your seeds, and you pump that out and spray it onto the landscape like you see with this fire hose here. And to help out with the hydromulching, we hired Taylor Marsh with Native Ecosystem Services. He's based on Oahu, but set up his whole rig out here and broadcasted the hydromulch over our plots. And then it's dyed green when you first apply it so that you can better see where you are spraying it. But once it's on the landscape for a few weeks, it loses the green color and it looks just like kind of normal leaf litter, which you can see in the bottom left here. And in the bottom right, we actually had some extra hydromulch after we did our plots. So we went ahead and tried just spraying a big like gulch channel area where the water moves quite fast, just to see how well that would actually stay on the landscape after some rain events. The next treatments we tried were soil scarification in combination with outplanting seedlings that were actually grown in a greenhouse, as well as scattering that same mix of native seeds. And the species mix for our outplantings was actually a little bit different than the seed scattering mix. We had some different shrubs and trees like akia and kauai and nayo mixed in, but we didn't plant any ilima or uhaloa. And those plants are already pretty common on the landscape, so we saw a lot of those just growing on their own anyway. Oh, and we also planted clumps of peely in these plots as well. And so the soil scarification is something that Forest Solutions has had a lot of success with a bit higher up in the watershed where there's more rainfall. They hadn't tried it down here where it's quite so dry before, but the intended benefits are just to create some more topography, some depressions in the ground where water can soak into the soil and percolate in a bit better without just immediately running off of the smooth hill surfaces. There is, though, some increased risk of actually generating sediment that would be knocked loose and washed away. And so I think it helped a lot that we did this at the same time as we were irrigating, because that water helped, I think, contain a lot of the dust and sediment. And we were also applying this to an area that was pretty flat, so it's not just going to all wash away when it rains. But it's also really useful just for loosening up some of these really hard sun-baked soils that it seems like the plants can have a hard time actually getting their roots down into. The last treatment we tried were these coir logs, and these are basically just like big like sausages filled with mulch or some kind of fiber. I think these have coconut fibers inside. And these are really effective ways to kind of slow down water and sediment in erosion-prone areas. So there's something that's been used in the past in Pelekane, and I think probably have a role in the future as well. But we really wanted to just see what the biological response is to these. Like if stuff accumulates on the uphill side of them, are there a lot of plants that grow really well in that? And you can kind of see some of that here. We've lifted this log away, and you can see a lot of uhaloa and Pla'ul hi'iaka growing out of that. Okay, so before I get into some of the results too, this is sort of a rough timeline of when the project was established. We did some baseline monitoring to just figure out what the current condition of the land is in late 2020. The treatments and the irrigation were all set up about a year ago in April of 2021, and that irrigation was applied until August of 2021. So our intention was to kind of get the plants through some of those driest, hottest years of the summer. And then the most recent monitoring that we did was in late February, early March of 2022. So nearly a full calendar year of these treatments being on the landscape. And there is a rain gauge located very close to this trial. And for a little more context, 2020 was a pretty dry year. There was about 10 inches of rainfall, which is quite low for this area. 2021 was a little more typical. There was about 15 inches of rainfall, but again, happening during these really infrequent heavy rain events. And we continued that nightly sprinkler irrigation through several really dry months at the beginning of the summer. And then toward the end of summer, we started to get a little more rainfall, and we tapered off the watering. We switched it to be like a deeper watering every few nights, and slowly reduced the amount of water until by the end of August, we were no longer watering at all. As luck would have it, September, October, and November of that year were extremely dry, and there was also no irrigation happening, but we were surprised to see that the seedlings didn't all keel over and die. It seems like they had actually established themselves well enough to weather those dry months, which is a really good sign. This last December, in early December, we had some pretty heavy rainfall, but since then there has been very little in Pelekane, maybe an inch or two, according to those rain gauge records. So every 3 or 4 months, we go out and lay down a bunch of quadrats and track a few different things about these plots. We track what species are present, how much vegetation cover they're providing, like as a percent of the plot, how much bare soil, how much litter is on the ground, as well as the survival of those seedlings that we outplanted. And we also specifically look for new seedlings that are emerging in the plots, just so we get a sense of what seeds are actually germinating out there. So the preliminary results that we have, and yeah, I just really want to highlight that this is probably a trial that could easily go on for another year or two to see what some of these seeds with long dormancy periods end up doing. So these should really be considered pretty early analyses, just after like one full year, a full dry season, wet season cycle. But anyway, we found that when the trials began, the plots featured about 10% rock, about 15% plant litter cover, and 75% bare earth on average. So that's kind of an illustration of the problem here, just how much of that really fine erosive soil is exposed to the elements. And throughout the trial, this ground cover composition has stayed mostly the same. There hasn't been like a huge expansion of grass to really cover a lot of these bare areas yet. But you do see some interesting responses with the ground cover. So the green in these plots is organic litter, and the orange color is bare ground. And these two plots represent those hydromulching treatments that we were trying out. And you can see that right about here is where we applied the hydromulch, and the percent of litter cover jumped way up to more than 50% cover in the plot. And that has stuck around mostly for the 6 months since that August data point. which is good because we were kind of worried that we would apply this hydromulch, then as soon as it rains, it would just run off of the landscape. Uh, Obviously, that happens to some extent, but a lot of it has actually been able to stay on those plots, which is really good. And then this plot over here, this code means irrigated control. So these are plots that were receiving irrigation, but no other treatment beyond that. And you can see that we saw this actually throughout all the other treatments. The amount of litter has actually started to tick up as time goes on and more plants are growing on this landscape. And I guess I'll mention that even though like the amount of bare earth is still quite high, a lot of the vegetation, even if it goes slowly in terms of spreading outward, has grown really tall. So there's a lot of matter being produced on the landscape, and that sticks around and creates that litter layer, which is really good for improving the hydrology of the landscape. These plots are pretty dense. Sorry if they're overwhelming, but I'll do my best to kind of go through them step by step. And so these plots here show, if you're looking at a bird's eye view of these plots, what percent of them is covered by these different types of vegetation. And so it doesn't necessarily have to do with where the plants are rooted, just if you're looking down from above, where is their foliage covering the land surface. And so in this top row here, we have our scarification, our tilling treatments. And you can see that right after we did that tilling, the amount of veg cover dropped down pretty significantly because we were actually kind of mixing up that dirt. A lot of smaller plants got buried, a lot of grasses got kind of turned over sideways. And so that is kind of like an immediate negative aspect to the tilling, is you do kill some of the plants that are already there. But we were encouraged to see that pretty quickly after this, with the help of the irrigation, these cover fractions jumped back up relatively quickly, and nowadays are higher than than our readings before we applied any of the treatments. And let's see, you can see here this dark green color in the bottom of these plots. This actually represents native seedlings that we outplanted in the planted and tilled planted plots. And those proved to be a lot more persistent in the plots that we tilled. The survival was higher, the area coverage of those plants was higher. And so that's something kind of encouraging to see about those scarification treatments. If we move down into this next row here, on the left we have buffle seed scattering. In the middle we have native seed scattering, and on the right we have those coir log treatments, which didn't receive any seeds. And what we see is that these seed scattering treatments are broadly pretty similar to our irrigated control treatments. There's not a ton of evidence that those scattered seeds have really contributed a lot to vegetation cover yet. Some of them have been germinating, but they're still quite small, so you don't really see them factor into that percent area calculation quite so much. And one other interesting aspect is that the coir logs really seem to encourage some of these invasive forbs and shrubs like stylo and fireweed to persist and grow much larger. And I'm not sure if that's because maybe the coir logs actually have some invasive seeds in them, or they just create favorable growth conditions. It's still a very small percentage, but maybe something to keep in mind that they do seem to encourage that. If we move down into this bottom row, these are our two hydromulching treatments. On the left is the buffalo seed hydromulch, and in the middle is the native seed hydromulch. And on the right is just that irrigated control treatment. And these hydromulch plots did at the end of the day lead to relatively high amounts of vegetation cover compared to some of our other treatments. And in the buffel grass plots, these gains were really in large part due to the buffel grass. So there is some sign that when combined with the hydromulching, those buffel seeds are germinating and producing more vegetation cover. And then in the native seed hydromulch, we saw more of a native seedling contribution. But I should note there's a lot of variability in this data. It's a little unclear whether these were actually coming from native seeds that we scattered or seeds that were already on the landscape. There's a lot of Uhaloa and Elima seeds that are already out there, for instance. And then in these next plots, this is an alternative measure of plant density. And here we're only looking at seedlings, so new things that have recently germinated. And what this y-axis means is basically higher numbers mean the plant is more frequent, lower numbers means it's less frequent. And if we start back in those tilling plots in this top row here, you see that compared to all of the other ones, there is a big delay in seedlings actually popping up and germinating. And that really reflects, I think, the turning over of that soil. It buried a lot of the, maybe existing seeds that were on the surface and a lot of the grass. But it was encouraging because pretty soon after we did that tilling, Uhaloa, which is a native shrub, rebounded very quickly to levels that are comparable to the other treatments. But interestingly, though, if you look at the brown lines here, this is that invasive buffel grass, and the light blue line is the native peely grass. And those really seem to be suppressed in the tilled plots relative to the others. And so it does seem like for the grasses especially, there's some lasting negative impact of the tilling on the seed bank in those plots. You can see in a lot of these other treatments, there's a decent amount of peely grass in the blue line and an even larger amount of buffel grass. And again, these are just the seedlings that are popping up. And so it does seem like there's something to pay attention to there with the tilling. There seems to be a bit of a rebound after this latest wet season. Maybe things have had time to drop new seeds and those are now germinating. So, with another year of data, these trends may look pretty different, but it is an interesting response to take note of. And I also want to mention, if you can make out this purple line right here, this is our first A'ali'i seedling, and we know with pretty high certainty that this came out of seeds that we put on the landscape because, there hasn't been any A'ali'i there for a long time, first of all, but these seedlings only popped up in the plots that we did scatter that native seed mix. So it's not much, but there is indication that a full year after applying these treatments, we're just now starting to see some of these native plant signals, making themselves seen on the landscape. So that's really encouraging, and I think kind of highlights that we got to keep monitoring these for a while. If we move down into this middle row and look at the seed scattering, the buffel seed scattering that you see on the left produced a lot more buffel grass seedlings than the other treatments, except for the hydromulching with buffel. But if you compare this to the irrigated control plots, you see this kind of big jump up in buffel seedlings after the rainy season from 2020 to 2021. And then that kind of dips down throughout the summer and then bounces back up with this latest rainy season. And you kind of see that same pattern, but everything is just a lot higher in these buffel seeded plot. So it seems like seed scattering with buffel does actually create a lot more of these seedlings, which could eventually turn into more expansive vegetation cover. The native seed scattering plots are really pretty similar to the irrigated control plots. Nothing is no difference big enough to really be statistically significant. And so that's kind of an interesting sign that, you know, we're seeing really low germination from these native seed mixes. And with sourcing these seeds, there's always a lot of questions of, you know, how good was the batch that we put out there, how long they can actually stay dormant on the landscape. But it's something interesting to keep track of for sure. If we look down at the hydromulching, with the buffalo seed produced by far our highest amount of buffalo seedlings. And you can actually see it really easily on the landscape in those plots that were hydro-seeded with buffalo. There's a gazillion of these little seedlings poking out of the ground. They're still all very small, so it's kind of an open question how many of those are going to survive and actually create lasting large vegetation cover, but certainly an encouraging sign. And I think the fact that we had this first peak and then a decrease in those seedlings during the dry months, but then a rebound after the latest wet months shows that there is enough seed bank now in these plots to actually you know, create lasting generation of seedlings as opposed to just a big wave that immediately dies. If you look at the hydro seeding with native seeds plots, kind of similar to the scattering of native seeds, it's not really significantly different than the control plots as of yet. But you know, I have hope that, like we saw with those A'ali'i seeds, some of the native seeds might just be laying dormant, especially in the hydromulching plots because they have a little more protection from the sun. I have a feeling those seeds might last longer than the ones that are just laying out exposed to the elements. Okay, so those are the preliminary results from the plots where we were scattering seeds and applying those kinds of treatments. But we also had those plots where we were just outplanting seedlings. And so we specifically monitored each of those seedlings to see which species were most successful and just to track the general survival rates of those plants. And so this is sort of a time series of what proportion of those seedlings was still alive at each of these measurement dates. And so this first measurement period is a month after they were planted. And so you can see like Akia had already faced 50% mortality at this point. And then as time went on, we ended up losing all of the Akia by this last December. But a bunch of the other species seem to have actually kind of stabilized. They all faced some mortality, obviously, but the Kohala, the Nayo, and the A'ali'i all seem to have stabilized at roughly half of them dying and half of them surviving, which is not bad for such a harsh environment. And the Iliahi has stabilized at about 23% as well. And I say stabilized because I think it's really encouraging that in this really dry period we had from August through December of last year, we didn't really see like huge shocks of mortality, except maybe with the Akia, which sadly all died. And you know, this doesn't necessarily mean these species are completely ill-suited to this environment. There's a lot of variables at play here, like where we sourced those plants from, whether they were acclimated well in their greenhouse to the conditions out here. My guess is there's probably some improvement that could be made there. So, you know, Akia may be worth giving another try with some different tweaks involved. And these plots here show the height of each of those seedlings. And I think these are really interesting because it kind of shows the growth trends over those different climatic periods. And so on the left here, you have Kohala, and it has grown pretty consistently, regardless of like whether or not there was rainfall or irrigation. It seems pretty well adapted to the environment, and it's just shooting up at a pretty straight trend. But if you look at the Nayo and the A'ali'i, you actually kind of see There is moderate growth during the irrigation period, but then in those dry months, a lot of them actually kind of stopped growing and some of them died. But I think it's really encouraging that they were able to resume growth after those big December rains that we had. Uh, so yeah, you can use the heights to kind of track the different responses of plants to the rainfall, which is pretty interesting. So this is a lot of information to digest, and it's hard to convey over presentation using these graphs because there's also just a lot of observations on the ground that feed into this that kind of give us a better sense of what's happening. But my takeaways are that hydromulching with the buffalo seed was one of the things that really had an immediate effect on both creating a litter layer on the landscape, but also just creating tons of seedlings. Now, we still need to see whether these seedlings are going to survive or grow any bigger. I think it's possible that they might be rooted just in the mulch, but they might be having trouble actually penetrating the roots down into this pretty hard, compacted soil here. And so this is something we want to keep monitoring into the future. But hydromulching could be a pretty effective treatment at, seeding and getting litter cover on large bare areas that are near roads so that we can tow the equipment close to the necessary location. But the equipment and the supplies for this kind of work may not currently be available on the island, or they might be very costly. There's still a lot of unknowns there. And it's also interesting that so far it seems to be less effective with the native seeds. And so there could just be some lessons learned from this in terms of like maybe we need to apply the mulch thicker or use some sort of different component in actually creating the hydromulch. And we can consult with the experts in trying to figure that out. I think that the hydromulch could be used really effectively in conjunction with things like coconut coir logs that can help slow down water flow. I mentioned that we sprayed the hydromulch on one of those big gulches that was running through our plots. And unfortunately, a lot of that hydromulch did wash away. It generated some buffalo grass, but not much. And so I think if you combined the hydromulch with these things that can actually slow down the flow of water, maybe with some outplantings too, that could be a good way to stop the water from entering these channels, which is really one of the most erosive processes that happens on the landscape. Another unknown factor here is that we didn't try hydromulching without irrigation. I'd be kind of interested to see whether like this big explosion of seedlings was something that needed irrigation to happen. The other treatment that I'm really encouraged by is our outplanted seedlings, especially in the scarified plots. The scarification did seem to increase the seedling survival and also seemed to help those peely grass outplantings really grow quite fast. Some of the takeaways, though, as we saw previously, some of those species had much higher mortality than others. And maybe that's something that we can help fix by raising the plants differently or sourcing the seeds from a different place. I think we should try more Willy Willy in the future. We had a little bit out there and it did actually show a pretty good germination rate, but we just didn't put that many seeds out there compared to the other species. And so that's something I would definitely change in the future. And in terms of where the scarification could be really useful, like I said before, I think maybe some of these really bald, flat areas kind of at the tops of the hills in this watershed, a lot of them don't have many plants growing, and they don't have a lot of soil either. It's all been very compacted, and so it's hard for stuff to actually come back and grow. And so I think that'd be a good spot for doing some of these scarification treatments, either with the native seed scattering or outplanting, or maybe hydromulching if you wanted to combine both of those two treatments. And yeah, just to reiterate the fact that we saw those first A'ali'i seedlings a whole year after those seeds were scattered on the landscape. And so we could be seeing more seedling germination after whatever rainy periods we get in the coming year. Okay, so I'm going to shift gears a little bit now and go more into the land cover mapping, but afterwards we can take questions on all aspects of the presentation. This is an amazing map that John Stock and Corina Surovsky-Daryao made with USGS, mapping the areas of the Pelekane watershed that are producing the most erosion. And you see those in these red areas. And for context, our vegetation trial was right here in this big red splotch. And so this map was created through a really intensive effort that involved a lot of actual measurements on the ground of how fast different areas are eroding, as well as taking into account slope and land cover and all these different aspects. And so they found that these hotspots here they make up a pretty small area of the watershed, but produce a really, really outsized amount of the sediment that reaches Pelekane Bay. And so these are great spots to target for restoration, but we were curious if there is a way that you could more easily create a somewhat similar product without having to do this huge field campaign and make all these measurements. And so we really focused in on the land cover as the main thing that varies on this landscape that can really control how much sediment you're losing during these rain events. And so right here is a satellite image. This is actually provided by Andy McGowan at NOAA, who I think was on this call. And NOAA very graciously provided this imagery to assist with our planning efforts. And so this image has a resolution of 50 centimeters for some of the spectral bands. And it actually sees basically 8 different colors. The human eye only sees 3, but there's a lot more information that this satellite can see that we can't necessarily process. But by feeding it into the right kind of computer algorithm, you can take advantage of all of that information to really accurately pinpoint where you have bare ground versus sparse buffalo grass versus more dense grass. And you can kind of make out where those areas are just with your naked eye here. But if we take advantage of some of those different spectral bands that humans can't usually see, those bare soil areas get highlighted really well. Here they're kind of represented by this purple color, just to show how clearly you can see them from this image once you take all of those different spectral bands into account. And another thing I'll point out that's pretty interesting, this big swath here that is not very purple because it has pretty good grass cover. This is actually a younger lava flow. I think maybe about 150,000 years old, whereas the rest of the mountain is about 400,000 years old. And this part of the landscape features a lot less erosion, probably because the older lava flows feature a lot of fine ash deposits that are more erosive. So these flows are probably more rocky. They might maybe retain that water a little bit better. And also they probably discourage ungulates from grazing on them because they don't like walking on that more rocky terrain. So it's probably some combination of all of those aspects. But anyway, this yellow layer that I just put on, this is a layer from CCAP, which is a land cover layer produced by NOAA. In this case from 2010. I don't think there's a more recent one for Hawaii available yet, but there might be, and I might be out of date. But anyway, for us running our watershed models, this didn't really represent the current extent of the bare ground in Pelekane very well. And so using that great new high resolution satellite image that NOAA was able to share with us, we designed a custom trained machine learning algorithm. It's a pretty simple machine learning algorithm. For anyone who's familiar with them, it's called random forest. And using training data that we collected out in the field and from some drone images that we acquired, we were able to train the algorithm pretty well to pick out areas that had vegetation cover of less than 25%. And you can see here it's capturing most of those bright purple areas, and even some of these roads here, you can see these linear features kind of coming out in the classification. And so I think the big strength of this is that it can be repeated with somewhat minimal cost compared to doing like an entire field campaign to really map those erosion hotspots. And so once we know the different rates of erosion that are produced by the different types of land cover, which is what USGS was able to tell us with their study, we can kind of apply those same rates to updated land cover maps of the watershed. And the other really interesting aspect of this is that not only can this help us plan where to devote our resources now, it can also help us track the response of the watershed to different management actions. So for instance, a lot of this area here, a lot of this yellow area is within a fenced paddock that recently we did goat population control in. And so it'll be interesting to see over the coming year or two how fast that might recover on its own, or whether there's any actions we can take to accelerate that recovery. And to that end, we do have a new image from February 2022 that NOAA provided us once again, and I'm currently working on producing a similar classification for that image. And so I will wrap up there, and I want to give a huge thanks to everybody who's been involved with this project. It's been a huge effort with multiple partners from the South Kohala Coastal Partnership, and it couldn't have done it without all of the people named here. And it's my pleasure to get to share some of those preliminary results back now. And with that, I can open up for questions. I honestly have no idea how long that took or what time it is, but maybe Bree can help me out, or Blair can help me out.
Thank you so much, Mike. That was very thorough and excellent. And you picked some great points to touch on. We have about 10 minutes. Feel free to come off mute, come on camera. Oh, actually, I see Avalon has her hand raised. Go ahead, Avalon.
Hey guys, I'm curious, are there plans in the future then to go back into this area and outplant native species in the future?
Yes. I think we're still kind of discussing sort of the future direction we want to take with this project. I think there's a lot of value in continuing to monitor a few of these treatments that are still showing dynamic changes. But then there are certain treatments like maybe some of the control plots and seed scattering that I think we could try new things with, like different seed mixes or different types of hydromulching, for instance. And then beyond that, I think, we've got this nice fence set up and a pretty good irrigation system. And I think in the long term, I could kind of see this transitioning from more of an experiment into an actual, dry forest restoration zone. But yeah, there's a lot of room to figure that out in the future.
Lehua.
Thank you, Mike. That was exciting to see. I know we met more frequently when the project was just getting started, so it's really interesting to see how it turned out, or how it is turning out. So one of the things you mentioned was about the seeds, the native seeds specifically, and maybe kind of putting a little bit more thought into where those are collected or brought in from, or how they're brought up in the greenhouse. Do you know if the majority of those came from our lands, or were they brought in from other kind of similar environmental geographic locations?
Yeah, really, Willie Rice is the person who would know a lot more about that, since Forest Solution handled the sourcing of everything. I get the sense that that maybe just from looking at them, like maybe some of the Akia, which had a really high mortality rate, looks like it was brought up in like a really moist, wet greenhouse, and so that maybe just experienced like some shock when it was put in this landscape. But yeah, I'm not too sure where most of the seeds came from. I think the Willy Willy seeds came from pretty local, and maybe the Kohala seeds as well. I think those maybe came from the Forest Solutions plots up the hill. But yeah, that's a great thing to kind of be conscious of in the future.
I'd love to get a copy of the presentation too, just so we have it. There's so much great information there.
Yeah, absolutely. And I'm probably going to write a bit of a like an updated little preliminary report to include some of this as well.
Thank you, Lehua and Mike. We have a question in the chat from Christina. Is there a plan to increase vegetation cover across more of the Queen Emma land? Take this one.
Were you going to chime in, Mike?
Well, I can chime in, but you would probably have a better answer, so you can go ahead.
Oh no, I was just so for this project in particular, we're continuing to work with the Nature Conservancy, as Mike mentioned, to continue monitoring. We do have ongoing work throughout Kauai High of these different type of exclosures and native planting areas. So we're continuing with that. And then, you know, just working with our partners and looking for additional opportunities of areas and grant work that, you know, might be a good fit.
So right now there's kind of a couple or several different kind of exclosures that have plantings in them across Queen Emma land.
Yeah.
For general restoration are still ongoing.
Yes, so restoration is continuing. And then for this specific project, I think we'll just kind of keep an eye out and, you know, see how the monitoring goes and see what might make sense moving forward. But definitely interested in that. The technology you showed at the end, Mike, which I had never seen before from the NOAA satellites. And so that, you know, might, I think, present some good opportunities as well. And we've been working with our lessee Parker Ranch to on different grant work to prevent runoff. So we have an upcoming Department of Health project that will hopefully be starting in the next fiscal year, and that will address, you know, improving access to the interiors, mitigating or improving the fire buffers, and then as well as working with Parker Ranch on that rotational grazing, because fire is an issue once you remove goats. We've been, you know, we found that is important to continue having more managed grazing to kind of keep that fire load in check.
Yeah, and it's great to highlight the ongoing work to mitigate those main stressors of fire and ungulates. You know, I think that in itself is going to do tremendous things for the watershed, and it will be really interesting to track that in satellite imagery or field monitoring in the future. And then if we see there are spots that are having trouble kind of coming back, that might be a good place to target these more restoration oriented practices.
Thank you, Mike and Lehua. For those of you who don't know Lehua or didn't get to in the chat, she is with Queen Emma Land Company. And we have another question in the chat from Rick Camp at USGS. Awesome presentation, Mike. Thanks for sharing and looking forward to seeing this project scaled up. Oh, just a comment.
Thank you. My pleasure.
Can I jump in and say something really quick?
Sure.
Great presentation, Mike. But I think it's going to be really interesting moving forward now that most of the goats or all known goats have been removed from the watershed, to see how kind of these larger areas recover in the absence of goats. And then, you know, I'm still really excited about looking for some grant funding to try to scale up some of the revegetation, you know, so gaining from that revegetation project and using that information to kind of scale up some of those plantings in those persistently bare areas of the watershed. So I'm hoping that in the future we'll be able to get some grant funding to do that in some, you know, specific areas.
Thank you, Carolyn. We have a question in the chat from Ryan Peroy at UH Hilo. Great presentation and work. Will be really interesting to see what happens in the next year or so. For the scarification plots, any measurements of whether or not that process is actually contributing to erosion by breaking apart intact soil structure?
Yeah, we haven't really taken direct measurements of that. We thought of kind of doing like some erosion pins, but ultimately decided it would be too hard to interpret the signal. Speaking very anecdotally, just from going out there like before and after rain events, I think the fact that we have these situated on pretty flat areas, and that they're not like, you know, it's not like we're tilling like a long trench. It's more like making little depressions and mounds next to each other. It seems like there isn't a huge amount of sediment actually like flowing off of the plots, and that the water actually percolates into those depressions. So I was nervous about it. I'm less nervous about it now. There is probably still some loss from the wind blowing away some of those fines like right after you do it, but I think that's where the irrigation really helped keep things down on the ground.
Do we have any final questions? We can probably take one more question before we wrap up. Thoughts, comments? I'm not seeing any. Okay, well, thank you so much, Mike, and thank you guys for joining. Mike, if you want to put, do you mind putting your email and my email in the chat in case folks want to get in touch with us? And feel free to visit our website. The presentation will be recorded and up there for later viewing as well.
Yeah, thanks everyone for coming.
Thanks
Thanks,
everyone.
Mike and Blair.
Thanks, Mike.
Aloha.
Aloha.